Hello and welcome to the session Token Hunt. It's a great pleasure and privilege to be back at HIP. My name is Thomas Naunheim. I'm a cybersecurity architect at glueckkanja and also Microsoft Security MVP. Feel free to follow me on one of your favorite social media. We have tons of live demos, and fingers are crossed that the system and the demo gods are with us. You will find all the queries that I will sharing during the presentation from my GitHub repository, and at the end you will find also a QR code for that one. So what is the agenda for today? I'd like to give a brief introduction into token theft and post-authentication attacks. And we will find some nice details in the Entra ID sign-in logs. I'd like to give you some insights about that. And later on, we have the pleasure to see a little bit what we can do with all the beautiful logs in correlation. So that starts with correlation between an XDR alert and anomalies by using the UBA. And also, at the end of the story, having a correlation between a sign-in, identity protection alert, and any activity that was made from this sign-in. Last but not least, we have also a quick look in token artifacts to find them from vulnerable endpoints by using Microsoft's latest feature called exposure management. All right, let's start with a quick introduction in token theft. So all of the demos and the attack scenario that I will show later on is relying on the following scenario. We have a phishing-resistant authentication on Azure AD or Entra ID joint device. As a result of this authentication on this device, we get a primary refresh token. Microsoft did a lot of stuff in the past to make it quite secure, so it should be bounded to the device. And the PRT, you may be already familiar with that one, is available on systems that are integrated to Microsoft Entra ID, and we have some single sign-on artifacts, and it also combines the identity of the user and the device. We can use this primary refresh token to get a refresh token, and the refresh token is also a long-lived artifact. And there's one special thing, and that is maybe a little bit different from an access token. An access token has always a particular scope to a resource. But there's something called family of client IDs, and that allows you that you can use a refresh token, for example, issued for Microsoft 365 workload like Exchange Online, and you can get also our access token for the Azure Resource Manager API, which is quite important if you like to manage your Azure resources. When we're talking about how all this token acquisition flow looks like, it's quite important to be aware of the token issuance flow and everything related to the security and policies that will be applied. As soon we're using a PRT to get a refresh token, or we're using a refresh token to renew a short-lived access token, for example, conditional access will be applied, and we have an evaluation of all our policies. There will be also a check for the identity risk, so identity risk will be evaluated, and we will have also checks like a user assignment if the consent policy applies, and so on. If we have an access token, there will be no additional evaluation. So it will be evaluated when we're using the refresh token to get it, but afterwards we're using them to get access to a resource. There's no particular enforcement, and as long as we have our access token, we can use it to get access to the resource. And the only way to have a re-evaluation by using conditional access, and we heard that a couple of times in the last days, is by using continuous access evaluation. So that means there's a change in the security posture, and we get enforced to be back to conditional access, be back to Entra ID as our identity provider, and once again, following the whole token issuance flow, and then also we have an evaluation of the conditional access policies. There's something else called session cookies, just to be on the same page, and that is also a long-lived artifact, and it will be used for single sign-on, for example, in the browser. And it will be issued not only by Entra, there's also a couple of SAML SSO providers or something like, let's take an example, GitHub. If you have single sign-on experience to GitHub and you have been assigned to GitHub, the GitHub IDP will also issue a session cookie. And when we take a look on session cookies in Microsoft Entra, there's a couple of things that we can explore. Some of them are related to telemetry, but there are also some of them that are related for single sign-on experience. And if you joined my session with Eric, we have shown how we can replay a session cookie to have also a replayed artifact and can steal a user session. Also, what I have shown in a session with Eric was there's a couple of ways how we can replay token. And in our session, we have been showing the scenario about compromising a client, like using a malicious Chrome extension, for example, or you get any way to exfiltrate the unencrypted, unbounded token artifact. But there's a couple of other options as well. So you can intercept the traffic between the client and the identity provider, Microsoft Entra, and try to steal the token from the encrypted HTTP traffic, because the token himself is not being encrypted. And another option is we have, for example, a resource provider, and the devs have done a bad job and have some caching of token artifacts on the web server, and then you can also steal tokens with delegated permissions. Of course, there's a couple of options that you can use to protect and mitigate token theft. And as I said before, when it comes to PRT, it's quite, we are quite in a good position. We can bound it cryptographically to the hardware of the endpoint by using the TPM. And if we are using device compliance, it's also some relation with the session key that is also secured by the TPM. When it comes to the refresh token, it becomes more complicated. We have something like token protection and token binding, something what we discovered in the session yesterday as well. But there's just a limited numbers of application that supports the scenario. And it's quite important, and I really like to underline this statement, it's really important, token binding and all the other stuff works only if we're using the web account manager as our token broker in Windows to get the token, because the web account manager is the central place for issuing or handling the token requests, and those component has access to the session key, and the session key, as we learned yesterday in the session, is our proof of position and is a central element of the token binding. There's a lot of other things that you can do, for example, require reroute authentication if Entra ID has identified some risk, and a couple of options for access tokens, including that we have maybe a CAE-capable tokens in place. We can use compliant network, something that Chris has shown in his great session. So there's no silver bullet solution. We are really in, how I'd say, an onion approach that a lot of things needs to be in place to make it hard for the attacker to replay tokens. But honestly, how we can identify if our protection and also the, how we can say that, security posture of the token is applied as part of a sign-in. There's a lot of details involved and included in the sign-in logs. And what I have seen in many customer engagements, most people are not aware of them or see all the details in the sign-in logs, but they ask themselves, what the hell that means for me, right? And the very first thing that we need to make sure is how we can build a correlation between a sign-in and what will be later being made as part of the sign-in by using the token, because the token will be used to get access to a resource and doing some stuff on behalf of the user. So maybe all of you are already familiar with the correlation ID, and it sounds really like the primary key to make a correlation, as the name said, right? But there's one big disadvantage. This correlation ID will be generated by the client. And client means in that way, it is the one that redirects and creates the authentication request, so it's not the IDP Microsoft Entra. And there's another detail in the sign-in log called original request ID. And that's quite important, this ID, because it will be also used as an identifier to following various requests in an authentication sequence. So if you start to authenticate to Entra and you have later on some other step-ups, you can follow this request ID. I have a good or bad example, depends on the view, what you like to see. In this case, we have global secure access. Global secure access sign-ins are interactive and non-interactive. And across over 1 hour, we still have always the same correlation ID. So it seems not be the unique ID that we are looking for. If you compare that with the original request ID, that seems to be more unique to a request to Microsoft Entra. But let's see what we can find else in the sign-in logs. There's something called unique token identifier. Hey, once again, another ID that we have here in place. And this unique token identifier is quite important. It is really something that will be passed through the whole token request process. And it's also available in the claims of the token. And what the application can do, or a resource, it can use the unique token identifier by checking the claims in the token and use them for the activity logs. So you can make sure that the token that has been issued by Microsoft Entra is exactly the same token that was used for doing some activity, for example, in an M365 workload, like reading mails or something like that. And if we take a look on this unique token identifier, it looks really unique. So for each request, we have a different identifier. And it's even available if the sign-in was not successful. So for example, in this case, there was not a satisfied conditional access policy or something like that. I'm not aware of all error codes. I guess some people will directly say what is this error code means. But let's have a closer look into an example that is also quite important to know, and that is the session ID. So once again, another ID that could be really helpful, because the session ID, as I already said before, we have some single sign-on experience, like a session cookie, and we like to track a single sign-on session across various tokens that has been issued. That could be, for example, if I'm starting a browser, have a browser SSO experience, access various M365 resources, and I like to bring it back. Was it exactly in the same browser session? So this is another example. Even the, for example, the request IDs are different, and Global Secure Access decided to use always the same correlation ID for a specific time. The session ID means, in this case, it is still relying on the same initial authentication, on the same SSO session that has been established. But what is the difference? And I have here, I guess, a great example that explains it a little bit more. So in this case, we have an original sign-in to an Azure VM, and we have also a sign-in to something called Windows sign-in, which is the logon initial authentication. And later on, we can see a couple of other sign-ins, also to the OneDrive client or to Global Secure Access. And all of them are sharing the same session ID. So that means that seems to be that we have a single sign-on session on this Windows device. And as part of this single sign-on session, we are requesting various tokens for accessing various resources by using the exact same single sign-on session. There's a lot of other token details in the sign-in logs, and I hope after the session you have some open eyes for that for the next time when you're checking out your sign-in logs. For example, there's a detail called incoming token types, and that includes what is the token type that has been used for getting another token? For example, did you have used a primary refresh token to get a refresh token, or have you used a refresh token for an access token? And there's a couple of scenarios, and sometimes you have none as a value for the incoming token type, and that is like an indicator that you have been using browser SSO, or there has been an authentication by typing in credentials or doing authentication by Windows Hello or something like that. So we are starting a new single sign-on session. And when we're talking about token protection, we have another detail in the sign-in logs that give us indicator if the request, the sign-in request, was made under the condition that the user has access to the session key and is in the position to bound the token to the artifact. The question was all the details that I have been shown, where I can find that, right? And you will find that in the sign-in logs of Microsoft Entra. And if we have the chance to see my slides in a few seconds, I will show that there's a couple of places where you can find Entra sign-in logs. You can get them from the Microsoft Graph API. You can get it from the Entra portal UI. You can get it by diagnostic log forwarding. There's also at least minimum 2 different XDR tables that contain sign-in logs. And I have a beautiful comparison slide that I like to show with you guys to show where you can find the different information, because it is a nightmare if you start deep into the topic. What is the right place to checking for sign-in logs, right? If you have Sentinel in place, Defender XDR or something like that. So yeah, that is something that I like to show. So give me, or the guys, a couple of seconds and maybe we
These are non-interactive sign-in logs, right? And there is a lot of them.
Yeah, so
those events.
Yeah, sign-in and non-interactive, both of them, yeah. Yeah.
So basically the only reliable place you can look at them is within Microsoft ecosystem, because if I try to ship them into my Splunk, I will never be able to pay that Splunk bill.
So that's an overall question, right? If you like, but in the end, you take a look on the Graph API, and I hope that third-party SIEM systems are using those data source, or maybe using the diagnostic log forwarding. That includes also the details. So it would be possible to get the details also in a third-party SIEM.
You really think that the Graph API logs can keep up with the stream of non-interactive logs?
When it comes to the details and the richness, yes. When it comes to streaming performance, it's a whole other story.
Yeah, okay, thank you.
That's I think, a fair point, right? Okay. So the idea that not only exists on Windows, so when we're talking about Mac OS, there's also a token broker. It's part of the Microsoft Company Portal app. And when we are talking about Windows, it's called Web Account Manager. And that's the central place, for example, if you have an application using the Microsoft Authentication library, it is not directly talking to Windows Hello for Business, to your credentials. It is forwarding the request to get a token to the token broker. And the token broker is a secure component on OS level that did all the requests and also have access to TPM and getting the initial credentials. And that is the way how, for rich application, the token flow should look like. When we're talking about browsers, it's a whole different thing, because a web application has not the option to have a direct communication to the token broker on OS level. So the browser is our, how I'd say, the man in the middle. The browser SSO is able to talk to the web account manager, to the token broker, and takes care with the session cookie that we have a similar single sign-on experience in the browser. And that's the reason, for example, why token protection, is not available for browser applications at the moment, because there's no session key, there's no direct communication to the token broker, and that is something that Microsoft needs to be resolved to get token binding in place. So there's a whole dependency when it comes to those components.
The browser is a user agent. It acts on behalf of the user. In Okta, it's a user agent. So the user agent needs to be able to mint the session, because Microsoft opted for proprietary
Yeah. And I think we should later have a coffee chat about that and using cookies for the coffee talk to make the components a little bit in the playground, yeah. All right, we are back on the slide that I have started to talk about. We have been going through all the details already. So the last one that I like to mention about the sign-in details is we have also some details in the sign-in logs if the token is capable for continuous access evaluation. And, which is really underrated, we get some information about the OAuth scope info. So we get some details, how powerful is the token, what are the API permissions that are part of the issued token. And we will see later what we can do in enrichment to understand how critical it is when such a token has been replayed, because if a token includes group read write all or some other sensitive API permissions, then we should have a particular look on that one. So back to the question, what are the sources where I can get all the details? I spent, since a year, a deep dive research on this topic. And I started in January this year, and I figured out it's beautiful that we have all the details in the portal and also in the graph better, but it's not available in the diagnostic logs, so everything that we can forward to Sentinel or third-party teams. And even in the ITDR advanced hunting table, sign-in events, it's not available. After complaining about all the stuff and figure out how I get the details, 3 months later, Microsoft did a good job and add all the details to the diagnostic logs. But as you can see, if you do some stuff in the XDR hunting table, sign-in events, it's still missing. So let's go to demos, and fingers are crossed, that we can see what we can achieve with all the details. So we are here in the XDR portal, and I'm using the sign-in logs, so everything related to the diagnostic logs. And Chris already mentioned we have, when it comes to global secure access, a table called network access traffic. And I built a correlation between the both tables. And now I got here some nice insights. So I see the session ID. Also, a side note, always use created date time as your timestamp and not time generated, because time generated is not the sign-in time. So there can be a delay between when the data has been ingested to Sentinel and when the sign-in was made. We see here the incoming token type, we see the token binding and all the other details. So, nice to have, but what we can discover so far. Let's have some examples. In this case, we have a primary refresh token involved, and as a result, the token is bounded. And the reason for that is we're using a mobile app, desktop app, and it seems to be the case that this was something in a communication, for example, to our token broker. When we have something else, like here, we have non-incoming token type, the token is unbounded, it was a browser app. So that really underlines my statements that I did before. But there are some suspicious stuff here involved. For example, here, I've got Microsoft Teams on a rich app. The token is bounded, but there was no usage of an incoming token type. So there was no primary refresh token or refresh token involved. And drum rolls, with the enrichment to global secure access, we can also see the process on the operating system that has requested the token. So when we have browser SSO, it should be something like the browser exe file, like Microsoft Edge, or the beautiful process called background task host, which initialized the token request. But PowerShell, sounds a little bit that something else is ongoing. We get also the original IP address and the IP address from the global secure access because the user was accessing the Microsoft Entra token endpoint by using the channel via global secure access. We see the location, But more important is this ASN, because the ASN is showing me if I'm still be within the same network provider. So even, for example, an IP address change, if I'm just getting a new IP address from the same ISP, so this number should not be changed. So a lot of things that we can discover. So now I have my suspicious bounded tokens without using session keys. And now I'm filtering for the session ID. And after I have looked for that one, I can see we have those non-incoming token types with bounded tokens from this PowerShell within the global secure access compliant network access, but a couple of other tokens that has been requested, but they have been accessed outside of global secure access. So that could be an indicator that someone has replayed the token and now accessing outside of the device, outside of the compliant network, and that could be something suspicious. But hey, why I have no conditional access policy in place and enforce using global secure access, as Chris already mentioned in his session? One of the nice things about this AAD sign-in event better that I mentioned before is you get all the details about the application, how conditional access policy has been applied. So for example, we can see what are the include or exclude rules that has been satisfied or not. And in this case, we can see all of this sign-ins was made from a user that was not in scope of my conditional access policy to enforce using a compliant network. So this is something that is not available in the diagnostic logs. So it could be a good idea to correlate these logs as well. With all the details here, I can now do some nice custom detections because, as I said, this is suspicious if I have a bounded token without relation to your primary refresh token or refresh token. And Chris has shown in this session that there is a tool out there called Bad Token Broker. And we talked about the task or the responsibility of a token broker. And there's a POC out there which allows you to have your own token broker. And it has direct access to the Windows Hello credentials and requesting tokens by themselves. So this was the case. So I've used Bad Token Broker to request a lot of refresh tokens. And with all the correlation that is in place, I can now use a nice custom detection. And for example, having here all the details involved, like, hey, this was some acquisition outside of the regular token broker. And another detection will looking for any token that has been requested by using this bad token issued token. And I can see, for example, that this was also a family of client ID token, and it was made outside of global secure access. So now we have some nice use cases how we can take benefit about all the details of our sign-in event. And let's bring everything together with this, I would say, a little bit complex KQL query. As I said before, you get all of them from my GitHub repo. And let's see what we can see so far. So we have here a sign-in, all the details like the various sign-in identifier. And one of the nice things is we have here what is included in the token. And in this case, application read-write all to Microsoft Graph as part of the API access. And I have some enrichment with my classification based on the enterprise access model, the tiering model. And that means this token has access to control plane. And in addition, I can see this is a non-CAE token, so I cannot revoke it after it has been issued. I can see all the details from global secure access, like it was not enforcing compliant network because the user was not part of the policy. And I get also some information about authentication context, because as I said before, we can use step-up authentication for certain things, and in this we can see we already satisfy authentication context C10, because, for example, user did already the step-up, or it is not part of this authentication context assignment. And also all the details about the sign-in. So with that in mind, we have a couple of options. And I need to speed up a little bit because I'm running out of time, but let's see how we can have some more fun with the correlation. And in this case, I had my very own custom detection. So I was aware that this is a suspicious behavior from getting a token, but we have Entra-ID protection in place, and there's a couple of detections out there, like anomalous token, unfamiliar sign-in. And all of this risk detections includes IDs like sign-in, request ID, and correlation ID. So now with all what we learned so far, that helps a lot to map the risk to the specific sign-in. And there's also out there a couple of post-authentication detections, like suspicious Microsoft Graph API traffic and so on. And we have also detections for suspicious session cookies, and Microsoft is so friendly and shared the session ID as part of the alert. And also, if you did a good job, like my very own custom detection, we have also the cloud session IDs as part of the alert details. But so much more. We have behaviors in Defender XDR, we have UABA, we have Defender for cloud, and all of them could have indicators that a token has been replayed or the sign-in was suspicious. But unfortunately, all of these data sources, all of the signals, have no request ID, session ID, unique ID available. So it's only the IP address, the user, and the timestamp. So feel free, having fun, to try to match that to the specific sign-in. And that is what I already did for you guys. So feel free. And let's start with the very first one and keep it simple. So for example, if we are using risk detections, we have a couple of risk detections in Entra ID, as I already said, and we get a unique token ID. But it cost me already 49 lines of KQL to have all the matching and mapping in place. But there's so much more. When we go to this one, I built also a correlation to my very own XDR detection that I built. And that includes also the mapping to the session ID and the unique token ID. And now if I do some work with an MDC alert, I'm using here all MDC alerts and try to map those ones to the session ID. And how I made this correlation is I'm expecting that the token is valid for 1 hour. It is coming from the same IP address. It is the same user principal name. And I did also some correlation with the activity. Sounds complicated, but it's super powerful. And let's see the result of this mapping. I have an MDC alert that someone has used these privileges to extract keys from a storage account. So that could be part of the persistence attack or collection. And we can see, as part of the correlation, all the raw events. Like, hey, this guy has been not only listed the key, he has also requested new PIM approvals or something like that. And we have all the mapping here in place. With the UABA, they did the same, using the time period to have the matching in place. And UABA is really powerful in Sentinel. You get some investigation priority score. And if I take a look on my victim, Mr. Spock did some really crazy stuff with his account. And we can see, for example, we have an investigation priority score of 4. And we can see, for example, this guy is also a VIP user because it's part of some sensitive groups. We can see details like the user agent. Well, that's not so interesting, but this one is more. UABA gave you feedback. Is it an uncommon volume of operations? Is it an uncommon country, uncommon ISP, uncommon access to a resource? And with that in mind, I try to map those one to sign-ins. And yeah, based on the IP address and time range, as I mentioned before. So that can be really, really powerful. So let's have a look how I did that one. So this is the whole correlation work that I did over the last month. So we have the request ID from identity protection. We have security alerts in XDR, including the request and session ID. We can use those one to have a mapping to the sign-in log. The sign-in log includes the unique token ID. We can have the mapping to global secure access. And we can use unique token identifier to, for example, Azure logs, Graph logs. And then we have also a session ID. And Microsoft makes it not simple for us to build the whole correlation. For example, the cloud app events, to that time for my research, includes only the session ID. So the only way, if we have no sign-in identifier in the activity log, is building a time window join, so that I'm expecting that the token was used within this time window of 1 hour, and using IP address, actor, and the target object to have a kind of mapping. But Microsoft understands my pain, it seems so, because they introduced some improvement in the mid of this year, and like to bring something called linkable token identifier to all of the logs by using the session ID. And you can see a couple of logs are supported. But one important log is missing, Microsoft Azure, right? Microsoft Azure is a big deal for us as a sensitive platform. And if you're using device code flow, you have still the same session IDs. So there's also some downsizes for correlation. So Microsoft's goal is that we have all of this claims from the token part of the activity logs in Microsoft 365 and so on. But I'm really in love with the Azure activity logs that are not mentioned, because what the Azure team is doing, they parsing all the token claims in the activity log. So each activity log includes all the claims, like when a token was being issued, when it is expiring, what are the authentication contexts involved, we have the session ID. And really nice, we get also authorization details. So for each activity in Azure, we get what kind of role is assigned to this activity. And that is really powerful for doing some great stuff. Because now I like to have the most complex correlation that we can achieve, or that I was expecting to achieve. I have started to write down a list of sensitive operations in Azure and Microsoft Graph, try to correlate ARM and Graph API requests to the sensitive list, and using exposure management to get the list of my sensitive assets in the environment, because exposure management has some logic to identify, is it a privileged group, is it a privileged user, and so on. And using the uncommon for user details in the cloud app events to see also some anomalous parts as the activity. So let's have a quick demo about that one. So once again, I have written the following query. We are close to 132 lines of KQL. And I'm looking once again to my suspicious tokens that we have seen so far. And now I can see there was not only an exfiltration of storage account keys, there was also, for example, some extension that has been written to a virtual machine, and some Graph API activities to applications. And in this case, we can see that, for example, a password, a credential was to an application. And it is not a sensitive application, so it's not, has no control plane permissions or something like that. But for me, adding a credential to a service principal is a sensitive action. So this helps a lot to figure out if a token replay was used to do some really bad stuff, really high privilege stuff. But afterwards, I said to me, yeah, there could be also some other bad stuff involved, like data exfiltration. So I did another query to look for any other suspicious activity. And the result is we get a list of all sensitive operations, including stuff in Exchange. And in this case, we have an activity to Exchange, so that someone started to send mails from the replay token, or by using the replay token. Or even we have some other activities, like in this case, the token has been used to create an inbox rule. So I really try to bring all activities from the replay token together. And we get also some IP tags, like is it used by a specific ISP? Is it an uncommon behavior? Is it made through global secure access? Is it CAE token? So all the details that we've seen so far are enriched in this log. So my goal is, with this session, that you become a really great hunter for tokens. And something else is really important. If you do user containment, you're disabling a user because you identify there has been a replay token, you need to make sure there's still no activity by using the token. Because if it's not a continuous access evaluation capable token, then it's still valid for maybe 1 hour. So it's really our mission to catch the activity and figure out what has been done by the token. And once again, I have tried to write that down by using KQL. And we get this following query. And you get on the left side the revocation timestamp and the activity. So after the token has been revoked, it's still valid, and the user is still doing some stuff via Microsoft Graph by using M365 workloads. And we get also, by using Azure, the details how long we feel the pain that the attacker can still use the access token, even we have no option to revoke that one. So for the last 50 seconds before we leave, I'd really like to give you some homework for proactive things that we can do. So we can use exposure management to find vulnerable devices. And exposure management shows you also if, for example, a primary refresh token or other token artifacts are available. And we have the pain of session cookies, right? So what we do with session cookies on the device. And those session cookies are also visible in exposure management. So if you have an admin profile on your device in a browser, you can also find the separated profile with the browser cookie, and using the hunting here to see, okay, this user cookie is used because I'm a member of a group and I have, for example, a privileged role to a virtual machine or something like that. So we have a combined view between attack path and a user cookie. And last but not least, yeah, I have also written a master check for that one. So if you're looking for your high privileged admins and like to figure out if primary refresh tokens and user cookies are available on devices with a high risk score, you can find it quite easily by using Master. The most important slide, feel free to get my queries, having some fun in hunting for tokens, cookies, and other goodies. And with that in mind, thanks for having me. It's always a great pleasure to be at HIP. And if you have any questions, feel free to reach out. Thank you.
And thanks for persevering through this. Any questions?
Why are you giving this one away for free? This is literally a business that you can build on it.
Okay, thanks for that. Thank you for.
We appreciate your sharing, because this is literally a business you can run.
Yeah, so I'm working for glueckkanja. We're running a SOC. So if you like to have more than that, we have also a service for that.
But the real question is, does it also work for service principal, suspicious? Because you are talking about user-based exposure.
Yeah. So I repeat the question. The question was not only if you can get the stuff as part of a managed service. The question was also about would it be work for workload identities? Partly yes. managed identities do not include session ID as far as I know, but there has been some improvements announced 3 weeks ago that some more details are available in the service principal logs, so for the application and service principals. And you can do that quite similar for that one.
Oh, he's trainable.
Yeah.
You can tell me 3 times and then I will get it. So, because the managed identities, they are so funky, they literally issue tokens for like that are valid for 28 hours.
Yeah.
If you extract one of those, they are irrevocable. Even if you remove groups in ARM, in RBAC, that seems a little bit iffy. So, both on the regular app-to-app accounts and calendar read-write all and all that cool stuff, but also on user-managed and system-managed identities. Seems scary because users, sure, clicky endpoint, but poorly written app, if you can point a finger, that is something is leaking, that would be great.
But Daniel, that's a really great feedback because it would be not a big effort to modify the existing queries to try to achieve the same goal with the service principal as long the details are available in the sign-in logs.
Not a big effort for you.
No, you have the option to modify. Feel free to submit to my repo. So it's all community driven.